Hi guys, welcome back. This is part 2 of episode 11 where in which we are going to cover non-access specifiers. Okay, so let's start non-access specifiers. Java provides a number of non-access modifiers to achieve many other functionalities. The static modifier for creating and modifying class methods, variables, and static nested classes. The final modifier for finalizing the implementations of classes, methods, and variables and hence limiting them. The abstract modifier is used for creating abstract classes and methods and hence making them compulsory to be either overridden or inherited. The synchronized and volatile modifiers are used for threading, multi-threading purposes, which we'll see in detail in the upcoming episodes. Okay, now let's start with static variables. The static keyword is used to create variables that will exist for a particular class regardless of the number of instances. Only one copy of the static variable exists regardless of the number of instances of the class. Static variables are also known as class variables because they exist for a class. Local variables cannot be declared as static. Okay, now static methods. The static keyword is used to create methods that will exist independently of any instances created for a particular class. Static methods cannot reference instance variables, so please make a note of it. It's an important rule. Class variables and methods can be accessed using the class name followed by a dot operator and the name of the variable or method. Okay, now let's see an example. This is a class instance counter demo. It has got a static integer variable num and it's initialized to 0. We have a getCount method, an add method, both are static, and a constructor which is calling add method by using static reference. So it's using the class name and the method name. Here's our main method. So we have printed starting with getCount. So initially it's going to be 0. So it will print started with 0 instances. Now there's a for loop over here which is creating an instance of this class. So constructor gets called, which in turn is going to call the add method and which will increment value of number variable. So after 500 iterations, it's going to print created 500 instances. Now since it's static variable, each time the constructor gets called, it increments the value. So after 500 iterations, it's going to have a value of 500. Okay, now final variables. A final variable can only be explicitly initialized once. A reference variable declared final can never be reassigned to refer to a different object. However, the data within the object can be changed. The state of the object can be changed, but the reference cannot be changed. With variables, the final modifier often is used with static to make a constant. This we have already seen. We can use final keyword with static in order to create constants. Now this is an example. So it's a test class, a value integer final variable, another final variable, and another string final variable. So there's a method change value. So if we try to change the value, if we try to assign to a different value, say 12, so it's going to throw a compile time exception because it's a final variable and you cannot change its value later. It's already given, it's final. Now final methods. Final methods cannot be overridden by any subclass. Final methods are mainly created for security purposes. So whenever a program does not want his work to be modified, he makes use of final keyword. This is an example. So the test class, do not change name method, it's declared as final. So if there's a subclass, if it tries to inherit this test class, it will not be able to change, it will not be able to override this method because it's final. So whenever there's a need, suppose if you want to program and you do not want your implementation to change, you can make use of final keyword. Now final classes. The main objective of using a final class is to prevent the class from being subclassed. If a class is marked as final, then no other class can inherit any feature from this class. So for example, public final class test. So you cannot inherit this class because it's final. Now abstract classes. An abstract class can never be instantiated. If a class is declared as abstract, then only purpose is inheritance. A class cannot be abstract and final because final class cannot be extended and abstract keyword forces inheritance. That is why we cannot use abstract and final together at all. If a class contains abstract methods, then the class should be declared abstract. Otherwise, the compile time exception is thrown. An abstract class may contain both abstract methods as well as normal methods. So here's an example. This is abstract class, abstract demo. There are two abstract methods. How do we make out if it's an abstract or not? If there's a semicolon instead of a body, it's an abstract method. See over here, there's only signature. There's only declaration and no body. So that is why we make out that it's an abstract method. Abstract method. An abstract method is a method declared without any implementation or body. The method's bodies or implementations are provided by the subclasses. Sorry for that. Abstract methods can never be final. Any class that extends an abstract class must implement all the abstract methods of the superclass, which is base class, unless the subclass is also an abstract class. So if there's a class A, it's extending an abstract class A super, let's say, then your subclass, which is A, either it should implement all the methods of the abstract class, or you must declare your class A also an abstract class. If a class contains one or more abstract methods, then the class must be declared abstract. An abstract class need not contain abstract methods. The abstract method ends with a semicolon. So this is an example, public abstract demo. No body, only declaration. This is an example, public class, abstract class, public abstract class, superclass. There's an abstract void method do. This is a subclass which extends superclass, and it's implementing do method. But if you do not want to implement this method over here, you can declare your subclass also an abstract, and then you can create another subclass which extends your this particular class and provides implementation for do method. Now the synchronized keyword. The synchronized keyword is used to indicate that a method can be accessed by only one thread at a time. Hence, no two threads can access a method simultaneously. The synchronized modifier can be applied with any of the 4 access level modifiers. So here's an example. Display details method. It's synchronized. So no two threads simultaneously can access this method. So that's the function of synchronized keyword. Okay, the transient modifier. An instance variable is marked transient to signal JVM to skip the variable when serializing the object containing it. Now we have not yet covered what is serialization. So this particular topic we are going to cover in the upcoming episodes. So stay tuned. As of now, you can make a note that this modifier is used in the statement that creates the variable preceding the class or data type variable. So if I have used this transient keyword, this object will not persist. That means that this particular variable, when serialization takes place, it's a process in which your class is converted to an object. So when your class will be converted to an object, this particular variable will not be stored. All other variables will be stored. So bk is going to be stored into your object of class, but limit bk is not going to be stored. So that's the function of transient modifier. Volatile keyword will be covered later in the upcoming episodes. Okay guys, this was it for this episode. I hope you liked the video. Thanks for watching and please subscribe to my channel.